On February 21, 2024, a bus-sized object fell from the sky and crashed into the Pacific Ocean. It was not a meteorite, a plane, or a UFO. It was a satellite, a European satellite that had been orbiting the Earth for nearly 30 years. A satellite that had witnessed the changes of our planet, the challenges of our environment, and the wonders of our science. A satellite that had outlived its mission and had been slowly descending towards its final destination. This is the story of ERS-2, the European remote sensing satellite that came back to Earth. ERS-2 was launched on April 21, 1995, from the Kourou spaceport in French Guiana. It was the second of two identical satellites, ERS-1 and ERS-2, that were designed to monitor the Earth's land, ocean, atmosphere, and ice. ERS-2 carried a suite of instruments, such as a radar altimeter, a scatterometer, a synthetic aperture radar, and a spectrometer that could measure various parameters such as sea level, wind speed, soil moisture, vegetation cover, ozone concentration, and cloud cover. ERS-2 was a pioneer in Earth observation. It was the first satellite to provide global and continuous measurements of the ozone layer, revealing the extent and evolution of the ozone hole over Antarctica. It was also the first satellite to map the entire Antarctic ice sheet, detecting its changes and movements. ERS-2 also contributed to the study of climate change, natural disasters, and human activities, providing valuable information for scientists, policymakers, and the public. ERS-2 was supposed to operate for only 3 years, but it exceeded all expectations and lasted for 16 years. It worked in tandem with ERS-1 until 2000, when ERS-1 was switched off. It then continued to work alone until 2011, when it was decommissioned. By then, ERS-2 had completed more than 86,000 orbits, covering a distance equivalent to 3,600 trips to the moon and back. It had transmitted more than 1.5 million images and more than 2.5 petabytes of data, enough to fill 500,000 DVDs. ERS-2's mission was over, but its journey was not. The satellite was still in orbit, at an altitude of about 800 kilometers, where it faced the risk of colliding with other satellites or space debris. To avoid this, ESA decided to lower ERS-2's orbit and bring it closer to the Earth's atmosphere, where it would eventually burn up. This process, called deorbiting, began in July 2011 with a series of 66 engine burns that depleted the satellite's remaining fuel. ERS-2's deorbiting took longer than expected due to the low atmospheric drag at its altitude and the unpredictable effects of solar activity. For nearly 13 years, ERS-2 was slowly falling from space, losing about 1 kilometer of altitude per month. ESA kept track of the satellite's position and speed and predicted its re-entry date and location. On February 21, 2024, ERS-2 reached the critical altitude of about 80 kilometers, where the atmospheric friction was so strong that it began to break into pieces. ERS-2's re-entry was uncontrolled, meaning that ESA had no way of steering or stopping the satellite. However, ESA assured that the risk of the satellite hitting anyone or anything on the ground was very low. Most of the satellite's parts would vaporize in the atmosphere, and only a few fragments, weighing no more than 50 kilograms, would reach the surface. ESA estimated that the probability of a person being hit by a fragment was 1 in a trillion, much lower than the odds of winning the lottery or being struck by lightning. ERS-2's re-entry was also spectacular, as the satellite turned into a bright fireball, visible from the ground and from space. The satellite entered the atmosphere over the North Pacific Ocean between Alaska and Hawaii at 12:15 EST, 17:15 GMT. It traveled at a speed of about 8 kilometers per second and generated a temperature of about 1,500 degrees Celsius. It left behind a trail of debris, some of which were detected by radar systems operated by NOAA. ERS-2's re-entry was the end of an era, as it was the last of the ERS satellites to return to Earth. ERS-1 had re-entered in 2011 over the Southern Ocean. ERS-2 had followed in 2024 over the Pacific Ocean. Together, they had left a legacy of scientific discovery, technological innovation, and environmental awareness. They had paved the way for the next generation of Earth observation satellites such as Envisat, Sentinel, and Copernicus, that continue to explore and protect our planet. ERS-2 was a testament to the ingenuity, perseverance, and vision of the European Space Agency and its partners. It was a reminder of the beauty and fragility of our home planet. It was a challenge and an inspiration for our future. It was a wonder of the world that came back to Earth.